Hello, everybody, and welcome back. In the previous sessions, we learned how to load, clean, filter, and manipulate data sets using Pandas. Today, we are taking the next big step in data analysis process. Before data scientists build machine learning models, before businesses make decisions, and before analysts create reports, they first perform something called Exploratory Data Analysis, or EDA. EDA helps us understand our data. It helps us answer questions like, what does this data set contain? Are there missing values? Are there outliers? Are there relationships between variables? Is the data suitable for analysis? By the end of this session, you know exactly how professionals explore data sets and uncover valuable insights. Let's get started. Now, what is EDA? EDA stands for Exploratory Data Analysis. It is a process of visually and statistically summarizing a data set before any formal modeling. It helps you understand its shape, spot problems, and form hypotheses. Think of EDA as investigating a data set before making decisions. Imagine somebody gives you a huge spreadsheet containing thousands of rows. Would you immediately start building a machine learning model? No. You first need to understand the data. EDA helps us understand structure, discover patterns, detect errors, find missing values, identify outliers, and generate hypotheses. EDA is often the difference between a successful project and a failed one. So now let's begin by loading our datasets again. So here we import pandas as PD. Then we load our dataset. Before doing anything else, let's examine its size. That is our dataset.shape. Sorry, let's print this and run the program again. So you see the output here. This means our dataset has 100 rows and 9 columns. Immediately we know how large our dataset is just from this simple line of code. Then we know how large our dataset is. One of the first command every analyst run is our dataset.info. That is the first command almost every analyst runs. Let's run it and see. So when we run it, it provides us with the column names, the data types, the missing values, memory usage. I call this the health report of our dataset. Whenever I receive a new data, run this info function first. Then you see the column names here, the data types over here, the missing values, and the other details that you need in your data set. Now let's summarize the data set. In summarizing the data set, we use the describe function. If you use the describe function, this should summarize the data set for us. and we see the summary of our data set here, which gives us the counts, the mean, the standard deviation, the minimum, the maximum, the quartiles, all from this data set for numeric columns. This single command can instantly reveal valuable insights. Now let's understand how values are distributed. So, for example, let's see, let's look at one of the columns in our data set. Let's take the customer name column. So, want to understand how values are distributed. Want to access this. Want to access this. Let's check the. Okay, that is it. Now let's run this code and see. Now, this is a statistical summary of the customer name column. Starting with the count, it shows there are 100 entries in the customer name column. The unique value of 100 tells us every single name is different with no duplicates. Now, the top row indicates the most frequent value, which is this name here. And the frequent value under here of 1 means that that name only appears once, which is this name only appears once in this column of our data set. If the maximum value is much larger than most values, there might be outliers. This is why descriptive statistics are so important. Now, let's analyze some categories. Suppose we have a product column. A product column. Let's try to see its value counts. Let's run this and see. Now, this shows how many times each product appears. Example, the first product here is laptop. It appeared in this data set 13 times, sorry. Phone appears 13 times, monitor 12 times, webcam 12 times, tablet 12 times till the end. So it shows how many times each product appears. That is, if you take another column, see customer name, and we replace this product here with customer name, it will show how many times each customer name appear. Let's try this and see. Customer name. Let's clear the terminal here and run it. It shows the number of times each name or each customer names appear. So you can see all the customer names appeared only once in this data set. Now we know how records are distributed. Another useful command is the unique. So let's try that command and see something. Let's run this and see. Now, this tells us how many unique values exist in each column. Why is this important? Because it helps Let's distinguish IDs, categories, and continuous variables. Understanding data types is a major part of EDA. So we can see that in cell ID column, there are 99 unique values here. In dates, there are 73 unique values. Customer name, 100 unique values. This means that those values only appeared once. They were not repeated, or there are no duplicates of those values. So the cell IDs with no duplicates are 99. The dates with no duplicates are 73. That is just it. Now let's check data quality. So in this same data set, let's run this command, which is the is now function and the sum of all of those missing values. Let's run this and see. Okay, this tells us how many missing values exist per column. Missing data is one of the most common real world problems. Ignoring missing values can produce misleading conclusions. So in this data set, we can see in these columns, like the cell ID column, there is one missing value. Aside that, all the other columns are free from missing values. There are no missing values in the other columns. That is why we see 0, 0, 0s here. But in the cell ID, we have one missing value there. So let's check to actually confirm if there's a missing value here. We can see in this cell ID in the data set, we have now here. Now, let's examine some relationships. And let's use this command to examine some of the relationships. That is a correlation of numerically being true. Okay, let's run this and see. Yeah, so this creates a correlation matrix. Correlation values range from -1 to +1. +1 means strong positive relationship. -1 means strong negative relationship. 0 means no relationship at all. So this helps us understand how variables move together. Now, I've been mentioning outliers, outliers. You might be thinking what outliers are. So outliers are values that are unusually far from the rest of the data. For example, most sales value like 100, 120, 110, 130. Then suddenly we see 5,000. So we have sale values like 100, 120, 130, or 180. Then suddenly you see something like 5,000. This might be an outlier. This 5,000 might be an outlier. Outliers can represent errors, fraud, rare events, or important business opportunities. Never remove outliers without investigation. This 5,000 might actually be a real thing that is there. So you have to, before you remove it, you have to investigate. Otherwise, you can remove a real data. Now, when performing EDA, I recommend this workflow. Step 1, check the shape, which we did from the beginning. After that, you move on to the next step. Run the info command to check the informations of the data set. Then you check for missing values. That is the is now command with the sum to sum all the missing values. Now, after that, we run the describe function to see the summary of the data set. Then we check the value counts. That is the next step. Then we analyze the correlations in the data, then investigate some outliers. Following this process ensures you never miss important information. So now, real world example, imagine a bank wants to predict loan defaults. So imagine a bank wants to predict loan defaults. Before building the model, analysts perform EDA. They might discover missing customer income values, probably unusual loan amounts, strong correlation between debts and defaults. These insights guide the entire project. That's why EDA is one of the most valuable skills in data science. Now, some common mistakes that beginners make are skipping EDA completely, just jump right into the data analysis, do whatever you're asked to do. No, it is very wrong. You have to go through the EDA process first before you go ahead with whatever you have to do. Another mistake beginners make is ignoring missing values. You have to always check for missing values, otherwise it can impact the data analysis that you're coming to do. Now, another mistake is trusting correlations blindly. Remember, correlation does not imply caution or something. Just because two variables move together doesn't mean one causes the other. Now, so the fourth thing or common mistake beginners make is removing outliers without understanding them, which is this 5,000 we talk about over here. Now, let's take the assignment for this session. The assignment is run a complete EDA on a data set, then find the shape, the data types, the missing values, and the summary statistics of the data set. Then compute correlations, then identify some possible outliers. After that, you write a short paragraph explaining your findings. Bonus, create charts showing most important discoveries. So excellent work, everyone. Today, you learned one of the most important skills in data science. That is the EDA, which is Exploratory Data Analysis. Next session now, we will learn data visualization and discover how to transform raw numbers into powerful visual stories. So I'll see you in the next session. Thank you.